Hi dear all, welcome to the class on rotational dynamics. Today we have two theorems. One is known as the theorem of parallel axis and the other one is known as the theorem of perpendicular axis. So I have written the statements for both here. The first thing is called the principle of parallel axis, or it is called the parallel axis theorem. The statement is the mi of a rigid body about an axis is equal to the sum of its moment of inertia about a parallel axis passing through its center of mass and the product of mass of the body and the square of the distance between the two axes. So statement complicated, but we can take the example here. So in this figure you can see a rigid body. Okay. So moment of inertia of a rigid body about an axis. So something like this. If I want to find out the moment of inertia of this body about some axis. So again an axis undennu vichchu. If I want to find out the moment of inertia of this body about a particular axis, I should take the moment of inertia of the same body about an axis passing through the center of mass. Center of mass എന്ന് പറഞ്ഞാൽ ഇതൊരു യൂണിഫോം ഡിസ്ട്രിബ്യൂഷൻ മാസുകളാണെങ്കിൽ ഇതിന്റെ സെന്റർ ഓഫ് മാസ് കണ്ടുപിടിക്കുക ഇങ്ങനെയായിരിക്കും. ഓക്കെ, സോ ഐ ക്യാൻ സേ ദാറ്റ് ദിസ് ഈസ് ദ പോയിന്റ് വെയർ ദി എൻറ്റയർ മാസ് ഓഫ് ദ ബോഡി ഈസ് കോൺസെൻട്രേറ്റഡ്. അങ്ങനെ പറയുകയാണെങ്കിൽ ഏകദേശം ഇവിടെ ആയിട്ട് ഇതിന്റെ സെന്റർ ഓഫ് മാസ് വരും എന്ന് വിചാരിച്ചു. സോ സംവെയർ ഹിയർ ലെറ്റ് ദിസ് ബി ദ സെന്റർ ഓഫ് മാസ് ഓഫ് ദ ബോഡി ആൻഡ് I should consider an axis passing through the center of mass. So what we are going to find out is moment of inertia of this body about any axis. So this is axis. So if you want to find out the moment of inertia of this body about this axis, what I should do first is that I should find the moment of inertia of this body about an axis passing through the center of mass. അതായത് ഇതിലൂടെയുള്ള moment of inertia ആദ്യം കണ്ടുപിടിക്കുക. എന്നിട്ട് അതിനെന്ത് ചെയ്യണമെന്ന് വെച്ചാൽ this moment of inertia of the body about the axis passing through the center of mass plus ഒരു പ്രോഡക്റ്റ് ഉണ്ട്, that is mass of the body and the square of the distance between first axis and the axis passing through the center of mass. So that is the statement. So again going to the statement, the moment of inertia of a rigid body about an axis, ഏതെങ്കിലും ഒരു axis. അപ്പോൾ ഇതാണ് വിചാരിച്ചത്, I have a rigid body here, I have some axis here. Okay, let x, y be an axis, some axis, and I want to find out the moment of inertia of this body about this axis. Let it be I. But I want to find out I. For that, I should consider the moment of inertia of the body about an axis passing through the center of mass. Here you can see that C is the center of mass. So I am considering another axis passing through the center of mass, which I have designated as x0, y0. So x0, y0 is an axis passing through the center of mass, and let I0 be the moment of inertia of the body about this axis x0, y0. അങ്ങനെയാണെങ്കിൽ from that I0 I can find out I. How? But from this equation, that is I is equal to, that is moment of inertia of the body about an axis is equal to the sum of, that is I0, that is the moment of inertia of the body about an axis passing through the center of mass, plus the product of mass of the body. Let m be the capital M be the mass of the body, then square of the distance between the given axis and the axis passing through the center of mass. So if A is the distance between the given axis and the axis passing through the center of mass, so you can multiply m by a, ma squared you will get, plus the moment of inertia about this axis, then you will get the moment of inertia about any axis. So this statement is moment of inertia of a rigid body about an axis, that is this one, is equal to the sum of its moment of inertia about a parallel axis. So these are two parallel axes we are saying, xy and x0, y0 are two parallel axes. So this is a parallel axis passing through its center of mass and the product of mass of the body, that is m, and the square of the distance between the two axes. But that is a, that is the distance between. അപ്പോൾ ഇതിന്റെ ഉപയോഗം എന്ന് പറഞ്ഞാൽ if I have to find out the moment of inertia of a body about some axis, and if I know the moment of inertia of the same body about an axis passing through the center of mass. Center of mass കൂടെ പാസ് ചെയ്യുന്ന ആക്സിസിൽ about ആയിട്ടുള്ള മൊമെന്റ് ഓഫ് ഇനർഷ്യ അറിയാമെങ്കിൽ ഇത് കണ്ടുപിടിക്കാം. എങ്ങനെയാണ്? In order to find out moment of inertia about this axis, moment of inertia of the body passing through center of mass plus mass of the body into square of the distance between the two axes. So in this way you can find out. ഇതിന് കുറേ ആപ്ലിക്കേഷൻ ഉണ്ട്. If I know one quantity, I can find the other quantity. അതാണ് ഇതിന്റെ ആപ്ലിക്കേഷൻ. So this is known as parallel axis because we are dealing with parallel axis. This axis which is given to me and this axis which is passing through the center of mass are parallel. That is why the name principle of parallel axis. Next one is the theorem of perpendicular axis. അപ്പോൾ അവിടെ എന്താ പറയുന്നതെന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ I have a lamina and I want to find out the moment of inertia of this lamina about an axis perpendicular to the lamina. ഇങ്ങനെ ഒരു ആക്സിസ് കൂടെ കണ്ടുപിടിക്കണം എന്നുണ്ടെങ്കിൽ so in order to find out the moment of inertia of this body or lamina എന്ന് പറഞ്ഞാൽ ഒരു പ്ലെയിൻ ഷീറ്റ് ആണ്. If this body about an axis perpendicular to the lamina, what I have to do is that can be given by the moments of inertia of the same body about two axes which are perpendicular to each other and also passing through the point where this axis is intersecting the lamina. So I want to find out the moment of inertia of this lamina about this perpendicular axis. അങ്ങനെയാണെങ്കിൽ എന്ത് വേണമെന്ന് ചോദിച്ചാൽ എവിടെയാണോ ഈ ആക്സിസ് ഇതിനെ ഇന്റർസെക്ട് ചെയ്യുന്നത് ആ പോയിന്റിൽ യു ഡ്രോ ടു പെർപെൻഡിക്കുലർ ആക്സിസ് ലൈക്ക് ദിസ്. ഇറ്റ് ഈസ് ജസ്റ്റ് ലൈക്ക് ദിസ്. If I want to find out the moment of inertia of this body about a perpendicular axis, about an axis perpendicular to this lamina, I have to take two perpendicular axes which is intersecting the point, which is passing through the point where this particular axis is intersecting the lamina. ഈ ആക്സിസ് എവിടെയാണോ ഇന്റർസെക്ട് ചെയ്യുന്നത് അവിടെ തന്നെയുള്ള രണ്ട് ആക്സിസ് കൺസിഡർ ചെയ്യുക. Then you take the moment of inertia. So for example, I am taking x-axis, y-axis, z-axis, etc. Moment of inertia of the body about this z-axis can be given by ix plus iy. That's the statement. Moment of inertia of a body about an axis perpendicular to this lamina can be given by the sum of moments of inertia of the body about two perpendicular axes. Which should pass through the point where the perpendicular axis meets the lamina. അതായത് ഇവിടെ ഈ പോയിന്റ് perpendicular axis is meeting the lamina at the point O and these two axes are passing through the point O. അങ്ങനെയാണെങ്കിൽ Iz, if Iz is the moment of inertia of the body about Z axis, that can be written to be equal to Ix plus Iy. That is moment of inertia about x axis plus moment of inertia about y axis. And the statement. Again going to the statement. Moment of inertia of the plane lamina about an axis perpendicular to its plane, that is this one, is equal to the sum of moments of inertia. Even though I have written short form as MIs, the actual plural is moments of inertia. Not moment of inertias, not like that. Moments of inertias of the lamina about two axes at right angles to each other. അതായത് ഇത് രണ്ടെണ്ണം. പിന്നെ എന്താ കണ്ടീഷൻ? Right angles to each other in the plane of the lamina. They should be lying in the plane of the lamina. ഈ പ്ലെയിനിലായിരിക്കണം കിടക്കുന്നത്. Because we are considering perpendicular axis. പക്ഷേ നമ്മൾ കൺസിഡർ ചെയ്യുന്ന മറ്റേ എക്സ് വൈ ആക്സിസുകൾ ഇവിടെ തന്നെ കിടക്കുന്നതായിരിക്കും. In the plane of the lamina. പിന്നെ അടുത്ത കണ്ടീഷൻ എന്താ? And passing through the point where the perpendicular axis intersects the lamina. So ഈ point. So this is a point where the perpendicular axis is intersecting the lamina. അപ്പോൾ ആ പോയിന്റിൽ കൂടെ തന്നെ ഈ രണ്ട് perpendicular axis പാസ് ചെയ്താൽ moment of inertia of the body about the perpendicular axis is given by the sum of the moments of inertia of the other two perpendicular axes. അപ്പോൾ ഇതിനും കുറേ ആപ്ലിക്കേഷൻ ഉണ്ട്. ഈ I am knowing this quantity. Okay, എനിക്ക് ഈ moment of inertia ആയും ഇതും അറിയാം എങ്കിൽ just sum up I can get this one. അപ്പോൾ നേരെ തിരിച്ചറിയാം. ഒരെണ്ണം അറിയാം. Suppose I know this one, moment of inertia of the body about this axis, and I know moment of inertia about this axis. അതും അറിയാമെന്നുണ്ടെങ്കിൽ I can find out moment of inertia about this axis. Just see Iz minus Ix can give you Iy. അങ്ങനെ. So knowing one quantity you can find out the other one. Okay, അതാണ് ഇതിൻ്റെ this has a lot of application when you are going to the next sections, that is you have to find the moments of inertia of some bodies, regular bodies, like we'll have a rod, we can have, then we can have a cylinder, then we can have a sphere, like that. A lot of bodies are there. So for finding out the moment of inertia of these bodies about the given axis, some axis will be given. അപ്പോൾ അതിനു വേണ്ടി നമ്മൾ മറ്റ് moments of inertia അറിയാമെങ്കിൽ, using that we can find out the moment of inertia through other axes, making use of these two theorems. അപ്പോൾ അതാണ് ഇതിൻ്റെ applications. Okay, now next session will deal with the proof of this thing. First we will deal with the proof of the parallel axis, and then we will have the proof for the perpendicular axis. So we are passing on to the next session, that is the proof of these two theorems. So first we will prove the parallel axis theorem. So I have redrawn picture here. Parallel axis theorem, the same picture I have drawn here. So where x0 y0 is axis passing through the center of mass, xy is another axis, I is the moment of inertia of this body about xy, axis xy, and I0 is the moment of inertia of the same body about the axis x0 y0. അപ്പോൾ നമുക്ക് കിട്ടേണ്ടത് ഈ ഇക്വേഷൻ ആണ്. What you have to get the equation is I is equal to I0 plus ma squared. So for proving that, we will consider a particle of mass m somewhere here. So I will consider a particle of mass m here, which is at a distance r from this axis. This axis passing through the center of mass. So r is the distance between this particle of mass m and the axis passing through the center of mass. Then we will write equation. Okay, what is the moment of inertia of this particle about this axis? We know that the moment of inertia is given by mr squared. So whatever be the particle that we are considering, mass of the particle into square of the distance between the particle and that axis. Above I can write mi of the particle about this axis x0 y0 is equal to, that will be m r square. Okay, m r square. So as we have already studied, ഇതെന്ന് പറഞ്ഞാൽ വെറും ഒരു പാർട്ടിക്കിൾ മാത്രമാണ്. We have a lot of particles. Okay, we have a lot of particles all over the body. So how will you find the moment of inertia of the whole body about this axis? അതെങ്ങനെയാണ്? That is by summation. Okay, so there are a lot of particles like this all over the body. If this is only moment of inertia of that single particle about this x0 y0, if I want to take the moment of inertia of the whole body about the axis x0 y0, I will have to sum it up. That is, from here mi of the body about x0 y0 is equal to sigma mr squared. So this is what we have seen earlier. Okay, then what is the moment of inertia of the same particle about this axis? ഈ ആക്സിസിലായതുകൊണ്ടാണ് നമ്മൾ mr squared എന്ന് എടുത്തത്. If I want to find out the moment of inertia of this particle about the axis xy, I will have to take mass into square of the distance between this particle and this axis. അപ്പോൾ ഈ ഇവര് തമ്മിലുള്ള distance now between this mass and this one, this particle and this axis is r plus a. So that is r plus a. So I can write mi of the particle about the axis xy is equal to m into, similar to this, here it was only r squared, now it is a plus r, so that is r plus a the whole squared. So moment of inertia of the particle about this axis will be this one. Then what will be the moment of inertia of the whole body about xy? just sum. You take the summation of this one. Okay, that is mi of the body. Mi of the body about xy is equal to sigma m r plus a the whole square. Okay. So what is the expansion of this one? I can write this as a plus b the whole square. So I can write sigma m into r squared plus 2a r plus a squared. Okay. So you can split. Okay. Now you write different times. I will write sigma m r squared plus 2 sigma m a r plus sigma m a squared. That is sigma m r squared plus 2 is a constant which should be taken out. 2 into sigma m a r plus sigma a squared. Okay. This a also can be taken outside. Why? Because this is a fixed distance. So I am taking this out also. So it should be 2a into sigma mr. Why we are writing sigma mr? A mass we will have a lot of particles. Here m is a mass of a single particle only. If you are considering different masses, they will be at different distances from these axes. But m change r change. I have put this in within the summation sign. Okay. So I can put this one also outside. Okay. This one also I can put outside because it is a constant. Okay. I can write sigma m squared a squared sigma m because a is a constant, because a, the distance between the two axes, I have taken to be a constant. Okay. So what will be that? So we will write the equation here. Now this can be written here. That is, moment of inertia of the body about xy is equal to sigma m r squared plus 2a sigma m r plus a squared sigma m. This sigma m r squared sigma m r squared m r squared means it is a moment of inertia of a single particle about this axis. What is sigma m r squared? That is the moment of inertia of the body about this axis. Okay. Already we have taken to be I0. What is I0? I0 is a moment of inertia of the body, not single particle, body about this axis. So this first term is nothing but I0. Other I0 then because it is a moment of inertia of the body about the axis x0 y0. xy anengil xy about moment of inertia IU ആണ്. So moment of inertia of the body about this axis x0 y0 is I0. So this first quantity is nothing but I0. So I will write here I0 plus. What is the second time? Second time is 2a and sigma mr and. What is sigma mr? This sigma mr is a moment. Okay. What is that moment? R. So this sigma mr, it is the sum of moments of all the particles of the body about this axis. To a mr. So sigma mr means you are taking the mr, it is a moment of a single particle. If you are taking sigma mr, it is the sum of moments of all the particles about the axis. Axis in the this is an axis passing through the center of mass. So what will be this term? Sigma mr means it is the sum of moments of all the particles about the axis which is passing through the center of mass. If the center of mass if it is a uniform mass, uniformly distributed body, so what do you mean by this thing? These are the moments rotating effect. Moment bar you might have studied for +1, +2, etc. While mass into this distance. If something is balancing like this, you say that some weights are added here. This mass into this distance will be equal to this mass. Common balance balance this mass into this distance will be equal to this mass. This mass into this distance. So you can say that if we are having a center of mass which is balanced about the center, the body is balanced about the center of mass, it means that the sum of all moments here due to different mass particles, it is 0. അതുകൊണ്ടാണ് ഇതിങ്ങനെ ബാലൻസ് ചെയ്ത് നിൽക്കുന്നത്. എവിടെയെങ്കിലും കൂടുതലാണ് ഇതിങ്ങനെ ടോപ്പിൾ ചെയ്യും, അങ്ങോട്ടും ഇങ്ങോട്ടും പോകും. So since the body is balancing about the center of mass, we can say that the sum of all moments of all particles of the body about this point will be 0. So what I am trying to say is that this term sigma mr is equal to 0 because this represents the sum of moments of all particles of the body about this axis. R ആണ് ഡിസ്റ്റൻസ് എടുത്തേക്കുന്നത്. ഈ ആക്സിസിന്റെ പ്രത്യേകത എന്ന് വെച്ചാൽ the body is balancing at that point because it is an axis passing through the center of mass. Center of mass എന്ന് നിങ്ങൾ മനസ്സിലാക്കേണ്ടത്, it is a point where the entire mass of the body is assumed to be concentrated. അപ്പോൾ അവിടെ ഒരു പോയിന്റ് വെച്ച് കഴിഞ്ഞാൽ അവിടെ ബോഡി ബാലൻസ് ചെയ്യും. Okay, so that this sigma mr will be 0. So this term is 0. So 2a into 0, that will be 0 plus. Then what is the next term? Next term is a squared, that is constant. Sigma m. What is the meaning of sigma m? M എന്ന് പറയുന്ന ഒരു ചെറിയ പാർട്ടിക്കിളിന്റെ മാസ് ആണ്. സിഗ്മ എം എന്ന് പറഞ്ഞാൽ എന്താ കിട്ടുക? സിഗ്മ എം എന്ന് പറഞ്ഞാൽ അതുപോലെയുള്ള ഒരുപാട് പാർട്ടിക്കിൾസ് എല്ലാത്തിന്റെയും കൂടെ മാസ് ആഡ് ചെയ്യുന്നതാണ്. So if you are adding small particles of different masses, you are getting sigma m, and that sigma m is nothing but capital M, that is the total mass of the body. If that is total mass of the body, total mass of the body എന്ന് പറഞ്ഞാൽ എന്താ, ഇതുപോലെ ചെറിയ ചെറിയ പാർട്ടിക്കിൾസ് എല്ലാം കൂടെ ആഡ് ചെയ്തുണ്ടാകുന്നതാണ്. So we can say that if I am adding up the masses of all the particles which are constituting the body, I will get the total mass. So I can write sigma m to be capital M, where m is the mass of the whole body. So in this equation, sigma mr squared is moment of inertia about this axis, which I have taken to be I0. Then second term is the sum of moments all these particles about this axis. Since the body is balancing about the center of mass, we can take it to be 0. Third term is a squared into sigma m. Sigma m is nothing but the mass of the body, so that will be multiplied by a squared. So it will be a squared into m. So what you are getting is moment of inertia of the body about this axis xy, that is nothing but I, that is equal to I0 plus moment of inertia about this axis plus this 0 plus ma squared. Okay, thus we have proved parallel axis theorem. Okay, now we will pass on to the proof of perpendicular axis theorem. Now coming to the proof of this perpendicular axis theorem, here we have this figure. So we have a lamina here, we have a z axis here, another two axes I am considering in the plane of the lamina. If I am considering two axes here. What I have to find out is the moment of inertia of this lamina about this axis. So we have to find out the moment of inertia of the lamina about z axis. For that, we are considering two axes, say x and y, in the plane of the lamina. That is what I have drawn here. This axis and this axis. I am considering a particle of mass m here. This particle p of mass m normal, you can see from the figure that this particle is at a distance r from z axis. Z axis il ninnu r distance ദൂരെയാണ് ഈ particle. At the same time, this particle of mass m is at a distance y from x axis. Because ഇങ്ങനെയാണല്ലോ നമുക്കറിയാലോ, because this point is situated at a distance y. When you are considering, this is the y axis. So along y axis it has moved towards the front. So I can say that this particle is at a distance y from x axis. Similarly, this particle of mass m is situated at a distance x from y axis also. This is the distance which was moved in the x direction. So distances moved in the x direction are taken as x. Distances moved along the y direction are taken to be y. So in short, this particle of mass m is situated at a distance r from z axis, y from x axis, and x from y axis. At a distance r from z axis, y from x axis, and x from y axis, because you can see from this figure. Okay. Let Ix, we have already stated this in this statement. Ix is equal to moment of inertia of the body about x axis. Iy is the moment of inertia of the same body about y axis, and Iz is the moment of inertia of the body about the z axis. So in order to find out the moment of inertia of the body along a particular axis, first we will have to take the moment of inertia of a particle. What is the moment of inertia of this particle about this axis OX? Moment of inertia of a particle of mass m from any axis is equal to product of mass of the particle and square of the distance between the particle and the axis. So I can write moment of inertia of this particle about the x-axis is my square. Okay, so I can write moment of inertia of the particle P about x-axis, okay, is equal to my square, because this particle is situated at a distance y from x-axis. So I can write my square. Okay, so therefore mi of the body, that means the whole body, about x-axis is given by. So this is only for a single particle. So if I am considering the whole body, there will be a lot of particles. So what I have to do is sigma my square. So this is sigma my square, because there are a lot of particles here. Particles so they will be at different distances from the x-axis. So what I have to do is I have to sum up all these moments of inertia of different particles. So that is sigma my square. Then what is sigma my square? This sigma my square is nothing but moment of inertia of the body about x-axis. Because I am summing up sigma my square, I will be getting the moment of inertia of the whole body about the x-axis. This is nothing but Ix. So I can write it as Ix. Okay, next one, moment of inertia of the particle P about y-axis. What will be that? This particle of mass m is situated at a distance of x from y-axis. So if I want to find out the moment of inertia of the particle about y-axis, I will have to take m into x square. Okay, so that will be mx square. So what is the next step? Therefore mi of the body about y-axis is equal to, so this is only for a single particle, so whole body it should be sigma mx squared. This is the, when I am taking sigma mx squared, I will be getting the moment of inertia of the whole body about y-axis. Moment of inertia of the body about y-axis we have already taken to be Iy. So that is nothing but Iy. Okay, I can write Iy. Then what is next? Next we will have to take moment of inertia of this body about the axis z axis. Okay, that I will write here. Similarly, moment of inertia of the particle about z axis is equal to m. What is the distance? M r square, because this particle of mass m is a distance r from z axis. So m r squared. Next step, mi, therefore mi of the body or lamina about z axis is equal to, steps are similar. First we will write my squared sigma my squared, mx squared sigma mx squared, then mr squared sigma mr squared. This is Iz, because this particle. This is when you are adding up all these things, we will be getting the moment of inertia of the whole body about the z axis. That is nothing but Iz. Okay. Now here you can see that sigma my squared is Ix, sigma mx squared is Iy, sigma mr squared is Iz. Then we have to look here. What is the relation between R, X and Y? What is the relation between R, X and Y? So here you can see that this is a right angle triangle. Okay, 90 degree. Because these are mutually perpendicular. So I can write, if you know, okay, R squared is nothing but X squared plus Y squared. So R squared is equal to X squared plus Y squared. This is nothing but Pythagoras theorem. Okay, R squared is equal to X squared plus Y squared. So what will be sigma mr squared? Sigma mr squared will be equal to sigma mx squared plus sigma my squared. Since R squared is equal to X squared plus Y squared, I can write sigma m multiply sigma m with all these things sigma m R squared is equal to sigma m X squared plus sigma m Y squared. So what is sigma m R squared? Sigma m R squared is nothing but the moment of inertia of the body about z axis. So that is Iz. So then this is Iz is equal to what is sigma mx squared? Sigma mx squared is the moment of inertia of the body along the y direction, which is Iy, plus sigma my squared is the moment of inertia of the body along the x axis, about the x axis. So that is Ix, or it can also be written as Iz is equal to Ix plus Iy. So this is nothing but what we have studied as perpendicular axis theorem. That is, the moment of inertia of a body about any axis which is perpendicular to the body is equal to the sum of moments of inertia of two axes, of the body about two axes which are taken to in the plane of the lamina and which are perpendicular to each other, and also which are passing through the point where the perpendicular axis is intersecting the lamina. Okay, this point, this point passing. Iz is equal to Ix plus Iy. This has got some application. If I want to find out this one, I can find out this one from this one and this one. If I know this one and this one, I can find out this one. Okay. If I know this one and this one, I can find out this one. Okay. So if you know the moment of inertia of a body about any two given axes, you can find out the moment of inertia of the same body about the third given if you don't know it. Okay. So that is the application of these two theorems. So in the next sessions we will pass on to the determination of moment of inertia of some regular bodies like uniform rod, then cylinder, sphere, then hollow cylinder, solid cylinder, then ring we have, okay, ring, then disc, like that. There are a lot of different bodies, and we will use these theorems to calculate the moment of inertia of those bodies. Okay. Thank you.